Hello everybody, welcome into another lesson. So today we are going to start solving trigonometric equations. And in today's lesson we're only going to solve for the value of x in the interval from 0 inclusive to 2 pi non-inclusive. So basically just the first revolution around the circle. Now, the general form of trig solutions will be in the next lesson, and we'll show you how to deal with solutions when they go on infinitely. But for this, we're just going to solve for the value of x in the interval from 0 is less than or equal to x, which is less than 2 pi. So here you have 3 sine of x equals the sine of x minus 1. So what you want to do, treat this like algebra. You'll want to get that negative 1 by itself, get the sine of x out of the right hand side. So this would turn into 2 times the sine of x equals negative 1, which would end up giving you that the sine of x equals negative 1/2. Now, where in the interval from 0 to 2 pi would you get a sine of x equal to negative 1/2? So this is where your special triangles come in. So pi over 6 being 30, pi over 3 being 60. So basically I have a 30, 60, 90 triangle here, but in radians instead of in degrees. And then next to it I have a 45, 45, 90 triangle in radians instead of degrees. But notice that the sine of pi over 6 is 1/2. Well, in the third quadrant and in the fourth quadrant, you would get negative 1/2. So that would have to mean that x would have to equal 7 pi over 6. And then in the fourth quadrant, you would get 11 pi over 6. Now, it looks like you found your solutions. However, what you want to then do is check these solutions in the original equations. Make sure you don't have any extraneous solutions. So, let's see. Let's take 3 times the sine of 7 pi over 6. We'll set that equal to the sine of 7 pi over 6 minus 1. Well, what is that going to give you? Sine of 7 pi over 6, that would be negative 1/2. So you get 3 times negative 1/2 equal to negative 1/2 minus 1. So that would give you negative 3/2 equals negative 3/2. So yes, that 7 pi over 6 actually checks out. Now we got to do the same with 11 pi over 6. So take 3 times the sine of 11 pi over 6, set it equal to the sine of 11 pi over 6 minus 1. So you would get 3 times negative 1/2. That would be equal to negative 1/2 minus 1, which would give you negative 3/2 equals negative 3/2. So that 11 pi over 6 also holds. So your two solutions to this particular equation for the interval from 0 to 2 pi is you get x equals 7 pi over 6 and x equals 11 pi over 6. And I got more. Alright, so let's see here. We are given the tangent squared of x minus 3 equals 0. So you have the tangent squared of x minus 3 equals 0. Well, this could simplify into the tangent squared of x equals 3 which would then mean that the tangent of x would equal both plus and minus the square root of 3. Well, where does the tangent equal either plus or minus the square root of 3? That's going to be at multiples of pi over 3, right? For the interval 0 to 2 pi. So it looks like you should get x equals positive pi over 3. And then, of course, in the second quadrant, you would get the negative square root of 3. So you would have 2 pi over 3. And then, of course, 4 pi over 3. And then, once again, you'll get it at 5 pi over 3. Now, of course, we have to go through and make sure that all these solutions are actually not extraneous solutions. So let's put each solution into the equation. So the tangent squared of pi over 3 minus 3 equal to 0. Well, the tangent squared of pi over 3, what is the tangent of pi over 3? That's the square root of 3, so you would take the square root of 3 squared minus 3, set that equal to 0. Well, 3 minus 3 equals 0. You get 0 equals 0. So yes, we can verify that pi over 3 is a solution. Now let's do this with 2 pi over 3. So take the tangent squared of 2 pi over 3 minus 3, set that equal to 0. Well, the tangent of 2 pi over 3, so keep in mind that's in the second quadrant, you would end up getting negative of the square root of 3, that quantity raised to the second power, minus 3 equal to 0. So you would get 3 minus 3 equals 0, and then 0 equals 0. So yes, 2 pi over 3 checks out. In fact, if we do 4 pi over 3, guess what? You're going to get the same result. It's, however, it's in the third quadrant, so it'd be positive square root of 3 squared, which would be 3 minus 3 is 0, and then 5 pi over 3 is in the fourth quadrant, which you would get that negative square root of 3 squared again, still giving you 3 minus 3, which is 0. So you have 4 solutions in this case from the interval from 0 to 2 pi. So x would equal pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those would be all of your solutions. All right, let's see here. Let's do, so we have 2 cosine squared of x minus the sine of x minus 1 equals 0. So this is where our trig identities are going to be so important, because yes, you definitely have a quadratic trig equation, but you have one cosine and then one that's sine. Well, we can make that cosine in terms of sine, can't we? We know cosine squared of x plus sine squared of x equals 1. So that means cosine squared of x would be 1 minus sine squared of x. So you could make this 2 times the quantity of 1 minus the sine squared of x. All that minus the sine of x minus 1 equal to 0. So you would end up getting 2 minus 2 times the sine squared of x minus the sine of x minus 1 equal to 0. So this would turn into 1 minus the sine of x minus 2 sine squared of x equals 0. Well, we can factor out a negative 1, so this would turn into positive 2 sine squared of x plus sine of x minus 1 equals 0. Now we can just treat this like a quadratic equation. Let me get some markers here. I thought they were going to hold, but I guess not. New black marker. See if I can find blue. I'd like to. No, we'll use purple. There we go. All right. So anyway, let's factor this. So you should end up having a sine of x, and then you'll have a 2 sine of x, still 1, and then a 1. So this would end up being a minus 1. This would be plus 1. Set all that equal to 0. Okay, so this should break down into the sine of x plus 1 times the quantity of 2 sine of x minus 1 equals 0. Well, set your sine of x plus 1 equal to 0. And then that would give you, of course, that the sine of x equals negative 1. Well, where in the interval from 0 to 2 pi is the sine negative 1? That's going to be a 3 pi over 2, right? So preliminarily, it looks like we got x equals 3 pi over 2. And then, so you're going to take that 2 sine of x minus 1, set that equal to 0. So you get 2 times the sine of x equals 1. So the sine of x would equal 1/2. Well, okay, so this is only positive 1/2. Where does the sine of x equal positive 1/2? It's going to be both in the first and second quadrants, right? So that means, let's see, it's going to be multiples of pi over 6. So you should get that x would equal pi over 6 and 5 pi over 6 for that factor. But we're not done yet. We want to verify that we don't have any extraneous solutions. So go ahead then and let's start with 3 pi over 2. Put it into your original equation. So 2 times the cosine squared of 3 pi over 2 minus the sine of 3 pi over 2 minus 1, set that equal to 0. Well, what is the cosine of 3 pi over 2? Well, that's going to be 0. You would just get 2 times 0 squared, which we know will go to 0. Now, minus, what is that sine of 3 pi over 2? That's negative 1. Then minus 1, set that equal to 0. So negative, is that 0, 0? Negative negative 1 is 1, minus 1 equal to 0. You get 0 equals 0. So yes, that 3 pi over 2 actually checks out as a solution. But what about the other two? Alright, so let's start with pi over 6. So 2 times the cosine squared of pi over 6 minus the sine of pi over 6 minus 1. Let's see if that equals 0. Now, what is the cosine of pi over 6? That's going to be the square root of 3 over 2. So this would be 2 times the square root of 3 all over 2 raised to the second power minus, what is your sine of pi over 6? So that's minus 1/2 minus 1, set that equal to 0. Square root of 3 all over 2 squared, well, that's going to be 2 times 3/4 minus 1/2 minus 1 equal to 0. Alright, so now what is 2 times 3/4? Well, that's 3/2 minus 1/2 minus 1 equal to 0. 3/2 minus 1/2 is 2/2, which is 1, minus 1 is 0. 0 equals 0. So yes, your pi over 6 is actually going to check out. Now, we got to do this one more time for 5 pi over 6. especially with quadratic trig equations, this is where you're a lot more likely to get extraneous solutions. So put in 2 times the cosine squared of 5 pi over 6 minus the sine of 5 pi over 6 minus 1, set all that equal to 0. So, okay, the cosine of 5 pi over 6, it's going to be like pi over 6, it'd be square root of 3 over 2, but since that's in the second quadrant, that would actually be negative square root of 3 over 2. So you get 2 times the quantity of negative square root of 3 all over 2 to the second power, minus, what's the sine of 5 pi over 6? Well, that's in the second quadrant, so the sign is positive. That'd be minus 1/2 minus 1 equal to 0. Well, that negative square root of 3 over 2 squared, that would end up becoming 2 times positive 3 over 4 minus 1/2 minus 1 equal to 0, which would turn into 3/2 minus 1/2 minus 1 equals 0, which gives you 0 equals 0. So that 5 pi over 6 also checks out. So let's go ahead now and write our answer. So x equals pi over 6, 5 pi over 6, and 3 pi over 2. So these are the 3 solutions we would get for x. X equals pi over 6, 5 pi over 6, and then 3 pi over 2. All right. We have the cosine cubed of x equal to the cosine of x. So the cosine cubed of x equals the cosine of x. Well, let's get all the cosines on one side. Let's make the right-hand side equal to 0. So that would give you the cosine cubed of x minus the cosine of x is equal to 0. Well, you can factor out a common cosine of x. So you get the cosine of x times the quantity of the cosine squared of x minus 1 is equal to 0, which would simplify further into the cosine of x times the quantity of the cosine of x plus 1 times the quantity of the cosine of x minus 1 equal to 0. So you have 3 factors. So of course, if you take that cosine of x and set it equal to 0, where does the cosine of x equal 0 in the interval from 0 to 2 pi? Well, you would get that x would equal, of course, pi over 2. That's where the cosine equals 0. And then you'd have it again at 3 pi over 2. All right, now cosine of x plus 1 equals 0. That's just going to give you the cosine of x equals negative 1. So where in this interval does the cosine of x equal negative 1? That'd be at pi, right? So x would have to equal pi. And then you're going to have the cosine of x minus 1 equals 0. So the cosine of x would equal 1. Where in this interval does cosine of x equal 1? We can only count 0 because 2 pi is excluded. It would also be 2 pi if we included it, but it's only 0 since we don't include all these. So let's check our 4 solutions for extraneous solutions. So let's put in pi over 2. What's the cosine of, let's see, so the cosine cubed of pi over 2 equal to the cosine of pi over 2 Well, what is the cosine of pi over 2? That's 0, so you get 0 to the third is just 0, 0 equals 0. So pi over 2 actually checks out. Now let's do the same for 3 pi over 2. So the cosine cubed of 3 pi over 2 equal to the cosine of 3 pi over 2. Well, what is the cosine of 3 pi over 2? That's 0, and 0 to the third is 0, equal to 0. So 3 pi over 2 also checks out. Now, what about the pi and 0? Alright, so take the cosine cubed of pi, set that equal to the cosine of pi. What is the cosine of pi? That's -1, so this would be -1 to the third power would equal -1, and it's true that -1 to the third power is -1, so -1 equals -1, so pi checks out. And we should know the cosine of 0 is 1, 1 to the third is 1, so that's going to check out also. So your 4 solutions for this are going to be x equals 0, pi over 2, pi, and 3 pi over 2 for this interval. So you get x equals 0, pi over 2, pi, and 3 pi over 2. Alright, secant squared of x minus 2 equals 0. So we have the secant squared of x minus 2 equals 0. Well, this could simplify into the secant squared of x equals 2. So then the secant of x would equal both plus and minus the square root of 2. Alright, so we have to figure out in this interval from 0 to 2 pi, where do you get secants of x that are both plus and minus the square root of 2? This is obviously referring to all 4 quadrants. If you have both plus and minus that square root of 2, well, definitely going to be pi over 4 multiples, so that's very nice to work with for the square root of 2. So you would definitely have x equals pi over 4. You'd have it again at 3 pi over 4 in the second quadrant, since you're including the negative square root of 2. And then you'd have it again at 5 pi over 4, since you're including the third quadrant. And then again at 7 pi over 4. Well, okay, let's check for extraneous solutions. Let's see if this holds up. So let's take pi over 4. So take the secant squared of pi over 4 minus 2, set that equal to 0. Alright, so what is the secant of pi over 4? That's the square root of 2. So this would be the square root of 2 raised to the second power minus 2 equals 0, which would give you 2 minus 2 equals 0, and 0 equals 0 is a true statement. So pi over 4 works because that's a positive secant, and the secant is also positive again at 7 pi over 4. Since your cosine's positive at 7 pi over 4, so will your secant be. So we verified 2 solutions right there. Now let's verify 3 pi over 4 and 5 pi over 4. We still have to do that yet. So let's do 3 pi over 4. So the secant squared of 3 pi over 4 minus 2 equal to 0. Well, what is the secant of 3 pi over 4? Well, this is in the second quadrant, so it would be negative of the square root of 2. So negative of the square root of 2 squared minus 2 equals 0. This would turn into positive 2 minus 2 equals 0, and 0 equals 0. So yes, 3 pi over 4 works. That's in the second quadrant where the secant's negative, and you would get the same result for 5 pi over 4 in the third quadrant. So all 4 of these solutions hold for x. X would equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right. I have, let's see, 1, 2, 3, 4. I should have 4 more. Should got 4 more here. So we have the tangent squared of x equals the sine of x times the secant of x. So we have the tangent squared of x equals the sine of x times the secant of x. Well, this is a good thing we know trig identities. So let's simplify the right-hand side. So we have tangent squared of x equals that sine of x. Now, what is the secant of x? That's the same as 1 over cosine, right? That'd be sine of x times 1 over the cosine of x. Well, what's sine divided by cosine? That's tangent. So what you really have is the tangent squared of x equals the tangent of x. So now we can make the right-hand side equal to 0. You'll get the tangent squared of x minus the tangent of x is equal to 0. This would factor into the tangent of x times the quantity of the tangent of x minus 1 equals 0. So now just set each of your factors equal to 0. So the tangent of x equals 0. So where in this interval from 0 to 2 pi does the tangent of x actually equal 0? Well, you would have 0 and pi, right? X would equal 0 and pi. We can't count 2 pi because that's actually excluded from your domain. Now let's take the tangent of x minus 1, set that equal to 0. You just got to figure out where the tangent of x equals positive 1. Well, it's going to be multiples of pi over 4, and we're only considering positive 1. Well, for sure you'll get x equals pi over 4. Now, what about 5 pi over 4? Because the tangent's also positive again in the third quadrant, so you could also have x equals 5 pi over 4. So it looks like we have 4 possible solutions, but looking like it and actually being it are 2 different things. So let's check for extraneous solutions. So, whoops, I didn't want to use that color, forgive me. Let's take the tangent squared of 0, set that equal to the sine of 0 times the secant of 0. Well, tangent of 0 is 0. 0 squared is 0. That would equal, what's the sine of 0? Well, that's going to be 0 times the secant of 0, which is 1. Well, you get 0 equals 0. That holds true, so 0 for sure is a verified solution. Let's do the same for pi. So we're going to take the tangent squared of pi, set that equal to the sine of pi times the secant of pi. What is the tangent of pi? That's also 0. 0 squared is 0. that equals the sine of pi, which is 0, times your secant of pi, which is -1. Well, you would get 0 equals 0, so guess what? Pi also works. Now, where it's going to get particularly interesting is your pi over 4 and 5 pi over 4. So let's take the tangent squared of pi over 4, set that equal to the sine of pi over 4 times the secant of pi over 4. Well, okay, so what is the tangent of pi over 4? That's just 1. You would get then 1 squared equals, what's the sine of pi over 4? That's 1 over the square root of 2. And there's a reason I'm not rationalizing my denominator. You're going to see why. Now, what's the secant of pi over 4? That's just a square root of 2, right? See how nice this is going to be? You'll end up getting 1 equals 1. So we know for sure pi over 4 holds, but it's going to get interesting for 5 pi over 4. So we have the tangent squared of 5 pi over 4 equal to the sine of 5 pi over 4 times the secant of 5 pi over 4. All right, so what is the tangent of 5 pi over 4? That would actually, again, be +1. You'd have +1 to the second power equal to, what's the sine of 5 pi over 4? So keep in mind, this is in the third quadrant. You would end up getting -1 over the square root of 2 times the secant of 5 pi over 4. Also in the third quadrant, you would end up getting times negative of the square root of 2. Well, 1 squared is 1. Well, the negative times negative turns it positive. Your square roots of 2 cancel out. You would just get +1. So all 4 of these solutions hold. So x would equal 0 pi over 4 pi and then 5 pi over 4. Those are going to be the 4 solutions to this particular trig equation. X equals 0, pi over 4, pi, and 5 pi over 4. All right, should have 3 more. So we have, this isn't going to be as pretty. We have 5 times the cosine of x minus 3 equals 0. Well, this would simplify into 5 times the cosine of x equals 3. The cosine of x would equal 3/5. Well, we're going to have to do a little bit of inverse trig. We want to figure out where you get a cosine of x that is positive 3/5. So you want your answer to be in radians because your domain is in radians, but you're not going to get it in conventional pi radians. So let's take the cosine inverse of positive 3/5. So you would get, if we do this to 3 decimal places, you would get x is approximately equal to 0.927 radians. And we know the domain of the cosine inverse function is going to be from 0 to pi, right? Well, if the cosine's positive, it gave us the first quadrant answer, that's for sure. Second and third quadrant would be negative, but the interval's from 0 to 2 pi. We need to find a solution in the fourth quadrant because the cosine's positive again in the fourth quadrant, right? So if we take 2 pi minus this, we should get an approximate solution. You should get approximately 5.356 radians. So x would be equal to approximately 0.927 radians and 5.356 radians. And I guarantee if you put both of these in, you would get that 0 equals 0. So sometimes you're going to have some not so pretty answers with decimals. Got two more. All right. 10 times the tangent of x minus 5 equals 0. So 10 times the tangent of x minus 5 equals 0, which would turn into 10 times the tangent of x equals 5, which then means that you would have the tangent of x would equal 5 over 10, or simply 1/2. So unfortunately, this is nothing we can figure out for x with our special triangle, so we're going to have more of the radians and decimals, but we want to do this in radians. So the tangent of x equals 1/2. This is definitely referring to the first quadrant because the domain of your inverse tangent function, remember, is from negative pi over 2 non-inclusive to pi over 2 non-inclusive. So when we take the tangent inverse of this, we're going to get a first quadrant answer. So let's take the approximation to 3 decimal places for this. Find the tangent inverse. That would give you approximately 0.464. So you'd have 0.464 radians, but also where is the tangent positive again? It's actually positive in the third quadrant. So if we add this to pi, we should get another approximation. You should get 3.605 radians. So x would be approximately equal to 0.464 radians and 3.605 radians. And then I should have one more. Good one. We have the cosine of x times the cosecant squared of x plus 3 cosine of x is equal to 7 cosine of x. All right. So let's see here. So we got the cosine of x times the cosecant squared of x plus 3 times the cosine of x equals 7 times the cosine of x. Well, let's get rid of that cosine of x term out of the right-hand side, make that equal to 0. So this would turn into the cosine of x cosecant squared of x minus 4 times the cosine of x equals 0, you can definitely factor out a cosine of x. You would end up then getting the cosine of x times the quantity of the cosecant squared of x minus 4 equals 0. So then this would give you the cosine of x times the quantity of the cosecant of x plus 2 times the quantity of the cosecant of x minus 2 equals 0. So you have 3 factors again. So let's set each of these factors equal to 0. Well, so that's going to then, of course, we'll have cosine of x equals 0. Where in this interval does the cosine of x equal 0? That, of course, is going to be at x equals pi over 2 and 3 pi over 2. And then, so let's take the cosine of x plus 2 equals 0. That would give us the, cosecant of x plus 2 equals 0. That would give us the cosecant of x equals negative 2. Well, where does the cosecant of x equal negative 2? Remember, cosecant is the reciprocal of the sine function. So the sine is negative in the third and fourth quadrants. This is going to be at multiples of pi over 6, so the third quadrant equivalent of that would be x equals 7 pi over 6. And then the fourth quadrant equivalent of that would end up being 11 pi over 6. And then, of course, let's take the cosecant of x minus 2 equals 0. Well, that would give you the cosecant of x equals 2. Where does the cosecant of x equal positive 2? In the first and second quadrant, so you would get x equals pi over 6, and then again at 5 pi over 6. It would look like we have 6 solutions, but do we really? Let's make sure of that. Let's check for extraneous solutions. So take each solution here. So we're going to take the cosine of pi over 2 times the cosecant squared of pi over 2 plus 3 times the cosine of pi over 2. Set that equal to 7 times the cosine of pi over 2. Alright, so what is the cosine of pi over 2? That's 0. Well, cosecant of pi over 2 would not be undefined. It would actually end up being positive 1. 0 times 1 is 0, plus 0, 0 equals 0. So pi over 2 checks out, and guess what? We're looking largely the same for 3 pi over 2, because your cosine of 3 pi over 2 is also 0. So we know for sure that pi over 2 and 3 pi over 2 work. Now, where it gets interesting are these pi over 6 multiples. So let's take the cosine of 7 pi over 6 times the cosecant squared of 7 pi over 6 plus 3 times the cosine of 7 pi over 6. Set that equal to 7 times the cosine of 7 pi over 6. And what do we get? What is the cosine of 7 pi over 6? So it's the third quadrant, it's negative. That's going to end up being, hold on. I'm going to write this better in a second. So that would give you negative of the square root of 3 over 2. Now, what is the cosecant of 7 pi over 6? This is in the third quadrant, so this is also going to be negative. That would be negative 2 over the square, sorry, that'd be negative 2 over 1. So you'd end up getting negative 2 squared plus what is, all right, so the cosine of 7 pi over 6 was negative of the square root of 3 over 2. So this would end up giving you, let's see, negative 3 times the square root of 3 over 2 for the cosine, which would equal then, of course, negative 7 times the square root of 3 over 2. Let's see what we get here. Let's see if the left side equals the right. Well, negative 2 squared is 4. 4 times negative 3, 4 times negative square root of 3 over 2 would end up giving you negative 4 times the square root of 3 over 2 plus that negative 3 times the square root of 3 over 2. Would that in fact equal negative 7 times the square root of 3 over 2? Well, as a matter of fact, it would. You get that the left side equals the right, so 7 pi over 6 checks out, but does 11 pi over 6? This is where it could get interesting, where all 6 solutions may or may not hold up. It's really going to depend. All right, so let's work with 11 pi over 6. So we're going to take the cosine of 11 pi over 6. This is in the fourth quadrant, right? Now, this will be times the cosecant squared of 11 pi over 6 plus 3 times the cosine of 11 pi over 6. Would that in fact equal 7 times the cosine of 11 pi over 6? All right, well, what is the cosine of 11 pi over 6? This is the fourth quadrant, so this would be the square root of 3 over 2 times, what's the cosecant squared of 11 pi over 6? Well, cosecant of 11 pi over 6 is 2. That'd be times 2 squared, which would be times 4, plus, again, the cosecant of 11 pi over 6 was the square root of 3 over 2, so you would have 3 times the square root of 3 over 2. And then, of course, you're going to have that equal to 7 times the square root of 3 over 2. Well, you end up getting the left side equals the right, so yes, in fact, your 11 pi over 6 does work. Now, what about your pi over 6 and your 5 pi over 6? I know this is a long one, but it's important to verify every single solution. So, let's see here. We need to take the cosine of pi over 6 times the cosecant squared. Well, actually, the pi over 6 should be the exact same as 7 pi over, as 11 pi over 6, first and fourth quadrant. So that'll hold up. And then the 5 pi over 6 would work the same as 7 pi over 6 in the second quadrant. So yeah, we have 6 solutions. So x would equal, let's start in order here, pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, and then you end up getting 11 pi over 6. So yes, we have 6 solutions to this. X equals pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, and 11 pi over 6. So that was it for solving trig equations for the interval from 0 to 2 pi. The next lesson we're going to do the general form of the solution of trig equations. So I hope everyone has a great day. Take care.